So we had the question robot collisions that was asked in the educational Codeforces around 109 that was conducted recently, and so this was one of the important questions. It wasn't one of the easy ones, and so this question was relatively uh, intuitive one, and what we can see is that we are given and robots are driving along the y-axis, and these robots are moving either in the left direction or in the right direction initially, and there are two walls. One is located at x equal to 0 and one is located at x equal to n, and for each robot we are given the location of where it starts, and we are given the direction in which it is headed over in the starting of the process. So this question requires us to output the time if 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 the robot collides to another robot, and output the time taken for the same, and obviously the speed of each robot is given, and it is equal to one unit change in any direction it is going. And so we obviously have some conditions, as you can see over here. The initial spots of 1, 2, 3, 4, 5, 6, 7 robots are given over here, and the direction in which they are heading is also given over here. So we see that one robot is heading in the right direction, two is heading in the right direction, three is heading in the left direction, and so on. So what we have as a condition is that no two robots can collide at a non-integer coordinate, and only when they arrive at the same digit coordinate at the same time they are considered to be collided, and then they destroy them there only, and then do not take part in any further collisions or any further movements. So what we can say is, as the after one time instant, we can say the robot number 4 has moved over here, 2 has moved over here, 3 has moved over here, and 1 has moved here. We can see these robots collided over here, 1 and 3, and 2 and 4 collided over here, and similarly these are moving in this direction. What the walls indicate are the turning points. So let's see if this of the robot number 7 has reached the point of the wall, that is the m equal to 12 over at time instant equal to 1. So at this point this will start to reverse the direction. So after one instant it will be here, and after another one instant it will be here. So what we can say is that when the reaches any wall, that is at x equal to 0 or x equal to n, it it turns back and moves in the opposite direction with the same speed of 1 unit per second, and is open for collisions in that direction. So uh, let's see what logic we will apply here. So let's head to so now what we can see is, let's have this as the road, and we have two walls, one over here and one over here. This is n, this is 0. We have a few robots, so please don't mind my time. These are moving, and these are integer coordinates. They do not, we don't consider any non-integer coordinates in any movements or any places. So these are moving in random directions. So what we can see is that if a robot collides to another robot coming in we cannot collide two robots going in the same direction at the same time, as when the robot the, as they have the same speed, they won't be at the same point if they haven't collided already, uh, unless they are going in the opposite direction. So this is one thing to keep in mind. So the two robots, let's say this robot was going in this. So if these two robots are going in these directions in any at any instant of time, at any separation other than 0, they cannot collide. So this is one thing to keep in mind. And another thing, what we can see is that once the robot reaches one of the ends, like this robot reaches over here. So let's say a robot reaches over here. This robot uh, has nothing new, but it just has changed its direction. So what we can see is that if we manage two arrays, one of the robots going from left to right and one of the robots going from right to left, then we can sort of see that which robots collide. This does not seem as a time efficient approach, but I can explain how this in real uh, execution can be a very good approach. So let's say as we this is our number line, and this is 0, and this is 1, this is 2, this is 3, and so on, and we have numbers. So we have these numbers, and let's say we encounter a robot at x equal to 2, and this is going in the right direction. So we add this robot to an array called right. So we have an array called right, and we add 2 to it. So this array has 2 right now. And then we encounter a robot at 3, which is going in the right direction. So we add to the end of right, we add another robot which is at, so we add 2, 3, and so on. So what we see is that as we go on to the right end, we add to the end of the array we have. So now let us see if we encounter a robot at 5, and this is going in the left direction. So this is going in the left direction, and we have an array called. Now we see at this point we have a robot going to the left at coordinate 5, and a robot going at the end of the array that is going to the right with the with the, so we check if 5 and 3 are both odd numbers or both even numbers, and which they are. But what we see is that in this case we would have to check 5 with every integer in the RT array, which is not a good method because then it would result in an n squared sort of time complexity. So what we will do is we will change our approach by by somewhat changing the way we want to do this. So what what we can do rather than what we are doing right now is that for for the even numbers like for 0, 2, 4, and such numbers, we will create an array for even, and similarly for odd we will create another array. This array will only consist of the numbers that are going from of the bots that are going from left to right, and not any robot from right to left. This we are doing because of the logic we want to play, if you can see. So what we do is check for each I over here. We check if this is odd or even, and according to that, we change the array which we are going to add this robot into. So let us see for this orientation we have 2 going in the right direction, and as 2 is even, we add this, and for 3 it is going in the forward direction as 3 is odd, so we add this to this. Now why we did the odd and even classification? The reason for this is that we no two bots at different odd and even can ever crash into each other. What I mean is that only two bots with this same mod 2, that is both the odd or both even, can ever collide because uh, if they are going in the opposite direction, they must be reducing the distance between them by 2 every time instant, as both have speed of 1 unit per second, and one increases by 1 and one decreases by 2. So this results into a 0 only in the case if both are odd or both are even. So what uh, for the condition of the walls also, let's say a bot runs into the wall at 0, and it was initially it was and bought initially at the array of evens. So let's say the bot at 2 turns into 0. So this bot now will perform in the same way but in the opposite direction, and this does not make any difference in the way we want to collide the bot. So this cannot now also collide into any other bot with the uh, which is in the odd array. So what we do is we want to add such and for any bot that is going in the left direction. So we encounter no bot at 4 and we encounter a bot at 5. Now the bot at 5 is going in the left direction, but 5 is an odd number, so it cannot collide in the even array, but it can collide there 1 and the odd bot. So we have the last odd bot in our odd array as 3. So the bot at 5 can only collide with the last bot in the odd array because that is the one which it meets first. So we collide the bot 5 with the bot 3, and this collision results in both vanishing, and the time taken for for these bots to collide is 1 because 5 minus 3 is 2, and at every instant the distance decreases by 2. So this only needs one instant to collide. So we keep a net array of the bots we had, and we in for like we had 2, 3, 5 bots. So we keep one over here, and non-initialized position over here and here. So this is the way we do for the odd, and similarly for the even bot. So let's say we encounter an even bot at 6, that is the 6 is an even index, and we encounter a bot that is going in the left direction. So this will definitely collide with the first bot that is going in the right direction in the even array, and that is 2. So 2 and 6 will collide, and that collision will happen after 2 instances. So this is for the arrays. For this is for the bots that have never collided with the with either of the bots. Now, let's say after some time, all the bots which were meant to collide during without colliding with any wall must have collided. So that can be 0 or any other instant. And after that, we must have left with the bots which have either collided or are yet to collide with any of the bots. So these robots must not have encountered any of the bots in between that are going in the opposite direction. That's why they are still intact. And these bots are not anything else, but only the bots that are left in the even and the odd array after we have iterated through the whole bots array. Then because all the bots which were meant to collide without colliding with any wall must have collided already and not being in the array, like 3, and 3 is taken out of this array as soon as it is collided with the bot 5, and 5 was never added to this array, so we are good. So what we have at the end are two arrays, one for the even bots and one for the odd bots, that must at least collide with the wall to get collided with any other bot. So now let's see how this happens. So let us go to uh, let us see how this can happen. So let's say we have the wall at 0 over here, and we have a bot at 2, we have a bot at 4, and these two bots are heading in the left direction. This is a possible orientation, and so the bot at the position 2 will be at 0 after 2 instants. So this will be at 0, and this the bot at 4 will be at 0 after will be at 2 after 2 instants. So but at time is equal to 2, we have direction reversal of the bot at which was initially at 2, and this will head in the opposite direction after hitting the wall. So we at instant 2 we have a bot in the even array that is heading to the right, and we have a bot at an even index which is heading to the left. So these will collide, and these will collide at a time that depends on both this distance, because this distance is this took 2 seconds, and the distance between them, which is just which takes time d by 2, because this distance is covered in half the number of time distance units because of what we, and next what we see is that d by 2 plus 2 is the amount of time required, and this can be now filled in the array which we were keeping for the finals, and so like 2 can be filled with 2 plus d by 2, and this can be done until, so like we are this is this can the question can have multiple so let's say we had a bot at 6, we had a bot at 10, and so on. So these bots will also collide if another bot is present at some even index after them, and these will collide in these pairs only. So the first two bots, the next two even bots, and so on. But if there are odd number of bots left in the even array after the initial iteration. We have that bot left over, and that bot will never collide with anything. So we have to return a -1 for that. And similar thing can be done with the other wall, and that is at m, and the distance in this case will be taken from m, and the odd or even orientation in that case will be similar as we took for the wall at 0, and also for the odd array, if the odd number of bots are left, then at least then exactly one bot will be left, and that will be given time of -1, as it will never collide with it. So we have the code over here. So we take two integer inputs, and the those represent the number of bots, and uh, the wall index, and the wall index, that is m. So we take the number of bots and this, and then we store the bot values, and then we create a map from the bot value to the uh, initial value of the initial orientation uh, of that. So we create a map from the bot index to the character, and that character can be either L or R, so the right or left. So then we go on to sort the bots in the order as we will iterate them from left to right, and this iteration can be seen over here. So we check if the bot is going in the left direction, and if it is going in the left direction, we check if the bot is in an even index or an odd. If it is it is at an odd index, we check if the result odd array is empty or not. If the vector result odd is empty, then we do nothing, but add we append we append the bot index to the array, and also the uh, also this number which is negative of the initial number, because this can I will explain later. So in this after if it is present, then what will happen is that the return the time instant for taken for this port and the second port which was already present will be equal to the what we discussed over there, which is the distance divided by 2. So and the last port that is present, and the result already will be popped up. So and this will happen for the ordering, and similarly for the even. But if the bot is not going in the left direction, that is it is going in the right direction, we add this to the result odd or the result even. And as after this iteration is complete, we have the bots which have collected without colliding into any other one. So after that we have either a non-empty result odd, or a non-empty result even array left, or both. So we check if the result order is empty or not, and if it isn't empty, we head on to assign time instance for the bots colliding, and that we discussed over here, where the odd indexes and the even indexes will be seen. So uh, we have the assignments over here, and if any bot will not be included in this, it will already have a return value of -1 as it was set in over here. So this happens, and uh, what this and uh, what this does was that uh, we do not have the initial ordering of the bots in the ascending order, but we wanted to iterate in the ascending order, so we change the orientation of an array of the initial bot. But we need the answer in the order of the initial bot specified, so we needed to create a mapping from the initial bot to the final bot, and that is implemented over here. And so we return this. So uh, what was happening over here, that is equal to this, and over here is that if if the result even array or the result odd array is uh, is empty, and then what happens is that the bot is going to the left, but these arrays are empty, then it will collide with the left wall, that is the x equal to 0 wall for sure, and this will just this can be just implemented as the bot was initially at some point that is minus of the initial index and going in the right direction. So what I mean to say is that if the bot was so what I mean to say is that if the bot was at some instant over here at some distance x, and this was from this and it was going in the left direction, it is equivalent to this bot, rather than being at this location, that is also x distance to the left of 0 and going in the right direction, as this will not have been collided, and these both will be at this position at at exact time of t equal to x. So this is what I wanted to say, and now what we can see is that if this boot gets accepted. So we see our code is accepted, and this is the solution.